Hello. So in this video, we're going to continue with the Pong tutorial, and we're going to get the top and the bottom walls in place. Now we could just do a very simple if statement, to make this kind of stuff work. But I really want to take advantage of defining everything as these objects that are interacting with each other, because that is when we get into more complex games and more complex programs. You almost need to have everything be organized as an object. So I'm really going to go with that kind of a style here. So if I want to make those top and bottom walls, then I'm going to define objects for them. I'm going to say let top wall equal an empty object, and then set top wall dot. Now I really only care about their y values here, so top wall dot y equal to 0, because that's what the top wall is. And I'm going to do a very similar thing for bottom wall. So let bottom wall equal an empty object, and then bottom wall dot y is equal to 400 here. Now I have these objects. They're very simple because they're really just lines. I don't have x, I don't have width, anything like that. If I wanted to have colors, I could put those properties in here, but I'm going to keep it very simple like this. So then I'm going to define a function that is for ball versus wall. And so function ball versus wall. And I do need the parameter of which wall that I'm talking about. I mean, it could probably just keep things very simple and just call it this way. So actually, let's go ahead and do that, because we really don't. In this example, we don't really need to specify too much which wall it is. And I think you'll see in the next step why that's the case. But I certainly could, but I'm not going to. So if some condition, then so if parentheses curly brace. So if the ball gets certainly past 400, then it's too low. It needs to turn around. All right. So if the ball dot position dot y is greater than the bottom wall dot y, then that is something that would cause it to bounce. And we'll figure out the top wall in a moment. All right. So if that's true, then we want ball dot velocity dot y to equal negative ball dot velocity dot y. And we only need to make it bounce in the y direction. So just set it to negative, to where it used to be positive heading downward. Now it's negative heading back upward. And so let's see if we can at least get that to work. Now I defined the function, so I need to call it as well. And before I do that, I'm just going to go ahead and change the name of this function slightly to say ball versus walls, because I know that as I go forward, I'm just going to include everything in this if statement. Right, so I do need to call this here. So it would be good to do, let's do it right here. Right. And the way I'm setting it up here, I didn't need any parameters. It just says to do this. But I think it makes the draw function very simple here. It's just these commands to do this thing, and then how exactly that works is just down here. So trying to see if I can get it to bounce off the bottom. Now I need to have some kind of a y velocity in order for that to happen. But I definitely got it to bounce off the bottom there. I know my picture cut it off. So that's good. So if we think about how to get it to bounce off the top as well. So this idea of it needing to change its y velocity is going to be true whether it hits the bottom or the top. So in this if statement here, I can say if the ball dot position dot y is greater than bottom wall dot y, or, right, so I use these pipe symbols, shift backslash, which is underneath the backspace. So if I do pipe, pipe, that means or. Ampersand, ampersand, like we have up here, means and, but this means or. Because if it's either the case that it hit the bottom or the top wall, that's just when it needs to flip its velocity. All right, so then in that case, if it's ball dot position dot y is less than 0, essentially, because it's too far to the top, it would start to go into the negative. But we did create these objects here, so if it's y position, if its downness is less than the downness, so to speak, of the top wall, that y. And if either of those conditions are true, then it should change its velocity here. All right, so let's see if I can get it to bounce off. And I know the collision with the paddle is a little bit different, but I did get it to bounce off the top there. So then we can think about how to mix in the width to make that just a little bit better. So when it hits the bottom wall here, if we just say ball.position.y, that's the center of the ball. So we want it to happen a little bit sooner. Right? So if that's the number getting too big, we want to add ball.width. So I would make that happen sooner. Or if the ball.position.y, we want that number to be smaller faster because we're trying to see if it's less than 0. So then I'm going to subtract ball.width. All right, so let's see if we can, it is a little bit tricky to see exactly with my picture here. All right, so trying to get the all right. It does kind of look like we're going in the wrong direction here. So it seems like it's bouncing off. If I change this y velocity to be something but have the x velocity, and if I change the y velocity to be a lot bigger, speed things up a little bit here. All right, so it seems like we actually we're doing a little too fast, and that's because I don't want width, which would be the diameter. I want the radius. Right, so if I, just like I did in the other instances, I need to divide by 2. Right. So, yep. So that matched it to where we're only dealing with the radius here, so it bounces off the edge of it. And just because we're in a rectangle, a square here, then we don't need to worry too much about the edges of the corners. Right. So we got the ball to bounce off of the walls there.